Academy, and today we are going to be looking at this problem from the past question. A diatomic gas assumed ideal initially at 23 points. Stop. Wait. Oh, have you like, share, and comment on my video? No be so then they do things so. I just say may I remind you. Eh? Okay. Try comment and share. Thank you very much. So now 23.7 liter. Okay. 0.9 bar and 308 Kelvin. So what? 38.2 liter. The question now asks you to calculate. So this is on episode 1. There are 4 questions here, but we want to solve question 1 and 2 first. Then we solve the rest later. So the question asks you to calculate the numbers of moles and hem marks. Okay, so the solution to this problem now is that we are using inertias to solve the problem. So how do you use the inertia? Because we don't know the mole. So remember PV equals to nRT. Okay, so N now equals to PV over what? Over RT. So what are the inertias? Inertial pressure from this place. This is your inertial pressure. P there, okay. Inertial volume in this place. This is your inertial volume. The V1 from there. The gas molar constant, which is R equals to what? 8.314. Then the temperature at which it is taking place. Now, the temperature for all the inertia is 308. Okay, so let's compute the data. But before you compute them, you need to do the conversion. So conversion now, what are we going to have? The pressure 0.9 is equivalent to 0.9 times 10 raised to power let's say 1 times 10 raised to power 5. That should give you 9 times 10 raised to power 4 Pascal. So that's one. The second one, the volume given here. The volume is 23.7 liter. We cannot use it in form of liter. We convert it. Divided by 1000. When divided by 1000, what would that give you? That should be 0.0237 meter cube. That is what you should add for that one there. So that is what we are going to use. So bring them down here. Your pressure, which is 9 times 10 raised to power 4 times the volume 0.0237, all divided by the gas molar constant 8.314 times the temperature at which it is operating is 308. So when you do the arithmetic of everything here, what do you have? You are going to have 0. That should be 833. If I am not mistaken, 833 mole. That is the one you are going to have there. So since you have solved for the question asks you to calculate the work done. Work done. So how do you calculate the work done? It's very simple, using the formula W equals to minus nRT, followed by, we are going to have 2.303 log V2 over V1. W equals to minus, we have calculated this one, 833 times the gas molar constant, that is 8.314 times temperature 308 times 2.303 followed by log of V2. What is the value of our V2? Which is, we have converted it before, and if you convert it, you are going to have a 0.038.2 2 rather. Please, in meter cube, take note of that. Then divided by 0.0237. That is volume in meter cube. Okay, so this one and this one are supposed to be there. So when you use this one to divide this, what are you going to have at the end? That is W equals to minus 0.833 times 8.314 times 308 times 2.303. If you use this to divide this, it will give you log of 1.6011. Okay, 1.6110 rather. So work done equals to minus 0.833 times 8.314 times 308 times 2.303. So log of this one, what would that give you? That will give you times 0.2070. Multiply all of them together will give you negative 10 followed by 17.35 joules. So that is how to calculate the work done. Now the question again asks us to calculate question 3, work done under isobaric condition. So the word isobaric condition here, when the pressure is kept constant. So what is the work done there? So with respect to that, you are using this formula, work done equals to minus the pressure, don't forget the pressure. So we are going to have change in what? Change in volume. Okay. So this one here, still the same value that we have used the other time. So we are going to have, that will be minus 9 times 10 raised to the power 4 times change in volume. This is volume 2, this is volume 1. So you are subtracting 38.2 minus 23.7 all divided by 1000. Please, the 1000 is to convert it to what? Is to convert it to to convert it to meter cube. Take note of that. That's the reason we are converting it. This is liter already. So that will be minus 9 times 10 raised to the power 4 times, when you subtract this from this, what should be the expected outcome? That should give you, and divide it, you are going to have 0.0145. Okay, so the meter cube there. So work done equals to minus 9 times 10 raised to the power 4 times 0.0145. The final value for heat should be minus 1305 joules. You can convert it to kilojoules as well. So let us now proceed to the last problem that we have there.